In section 6, we're going to build off section 5. If you recall, section 5 dealt with inequalities that occur within one triangle. In section 6, we're looking at inequalities that occur within two triangles. So the hinge theorem is the big one from this section. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is larger than the third side of the second. That's an awful lot of verbiage there in one theorem, so let's just kind of look at the diagram to understand what this means. In other words, if you know that these two sides and these two sides are congruent to each other, then the length of the third side is strictly dependent upon the measure of the included angle. Okay, in other words, the bigger the included angle, the longer the third side, the smaller that included angle, the smaller the third side. So in this diagram, it's pretty clear here that WX is going to be longer than ST. And again, that's based on the hinge theorem. The converse of that says if two sides of one triangle are congruent to two sides of another, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So again, let's slow down here for a second. We recognize one set of congruent sides, two set of congruent sides. So we're thinking maybe these triangles are congruent, but then we realize that it's pretty clear that 12 is bigger than 9, so they're not congruent triangles. But since the 12 is bigger, that means that this angle here, angle C, must be larger than the measure of angle F. And again, that's just going the other way now. Okay, the converse of the hinge theorem. So example 1 says, given that AD is congruent to BC, how does angle 1 compare to angle 2? Well, again, it goes back to the idea of, first of all, you should see reflexive property quickly. So now I have one congruent side, two congruent sides. So now if I look at the included angles, okay, here's angle 1, here's angle 2. Those are the angles between the congruent sides. It's pretty clear here that the side across from angle 1 is 34, and the side across from angle 2 is 33. So the measure of angle 1 has to be bigger than the measure of angle 2. Okay, strictly because 34 is bigger than 33. That's the converse of the hinge theorem. Okay, the length of the third side is longer. That means the angle has to be bigger. In example 2, it says if the measure of angle ADB is greater than the measure of angle CDB, which is longer, AB or CB? So in other words, this angle, ADB, is longer than this angle. Okay? Or I'm sorry, is larger than, not longer than, larger than angle CDB. So by rule, that means that the side across from this angle better be longer than the side across from that angle. And again, it all stems from the fact that you have two congruent sides. Look at the included angle. Okay, so AB would have to be the longer side here. Okay, so we're just completing greater than, less than, or equal to, and then we have to just quickly explain. Now, I'm not going to write down the explanation, but we'll talk about it. So in part A, it's asking you how does JL relate to ST. First of all, congruent sides, 60 is bigger than 59, which means ST has to be bigger than JL, or another way of saying that is JL is less than ST. Okay, it's less than ST, and again, that all comes from the hinge theorem. That is the hinge theorem. The included angle is smaller, so the side has to be smaller. In part B, I look at the diagram, I see one set of congruent sides, reflexive property. I see the third side here is 15, and the third side here is 14. So the angle across from the 15 is bigger than the angle across from the 14. So the measure of angle DEG is greater than the measure of angle FEG. And that's the converse of the hinge theorem. The third side's longer, the angle's longer, or angle's bigger. Okay, same idea here. Now, what you'll notice here is this. Okay, you have one set of congruent sides, two sets of congruent sides, and so now you look at the included angles. All right, you look at the side across from them. The side across from angle 1 and angle 2 is the same side. All right, and since it's the same measure, that means that they have to be equal. Another way you could have looked at this diagram is you could have said, well, as soon as I see the diagram, I recognize reflexive property. Therefore, these two triangles are congruent because of side, side, side. which means angle 1 and angle 2 have to be congruent because of CPCF. that is another legitimate explanation there in that problem as well. Okay, part D, we're looking at how AB relates to CD. So again, you have one congruent side, two congruent sides. 112 is bigger than 110, so CD has to be bigger than AB. Another way of saying that is AB is less than CD. Okay, example 4 says a car A leaves a mall, heads due north for 5 miles, then turns due west for 3 miles. Car B leaves the same mall, heads due south for 5 miles, then turns 8 degrees toward east for 3 miles. Which car is farther from the mall? Okay, so here's what we're looking at. Okay, the diagram's already labeled for you, so that helps out. So we know this, if this angle up here is 90, this one's got to be 90. If this angle's 80, that makes this angle 100. I'm just kind of filling in the blanks here. And so what you see here is you have one congruent side, two congruent sides. Look at the angle between them. 100 is bigger than 90. So the distance from the mall to car B has to be bigger than or greater than the distance from the mall to car A. So the question is, which car is farther from the mall? The answer to that question is very simply going to be car B. And your explanation, all you'd have to say here is the hinge theorem. Okay, that is the hinge theorem. 100 is bigger than 90, so the side across from the 100 has to be bigger than the side across from the 90. Example 6 says, use the hinge theorem to write an inequality to describe the possible values of x. So here's what I know. We have one congruent side, two congruent sides. Okay. I also know that the 33 has to be bigger than this because the 36 is bigger than the 30. So I know at the very least the 3x minus 3 has to be less than 33. Okay. Has to be less than 33. Now, we don't know a whole lot else about the angle measure. We don't know if it's the smallest angle in the diagram, the middle angle. It's clearly not the largest angle, okay, because the 60s are both bigger. So now I go to work here. I add 3 to both sides. I get 3x is less than 36. Divide both sides by 3. So x has to be less than 12. Now, using common sense, okay, that can't be the only restriction because clearly x cannot be 0 here. If x was 0, then you'd have a negative angle. So that's not going to work. So the other one that you have to solve is 3x minus 3 has to be greater than 0. Okay? And then you go solve this guy. So plus 3 plus 3. So 3 is less than 3x. Divide both sides by 3. So x has to be greater than 1. So x is anywhere between 1 and 12. If we knew something about this side length and another angle, we could set something else up, but that's all we know, so we can't draw any other conclusions other than what we're given.